Thank you very much. And I guess the first thing I want to say is for all the folks that are here and for all the folks that were part of our getting ready for this flight, it is with our sincerest thanks and appreciation. I think this flight was extremely complex, as we all know, especially those of us that are close to it. And we were trained for anything that potentially could have happened and kind of did happen. But we were ready for whatever the situation was, and we felt ready for anything that could possibly even happen. And I noticed that Mr. Abbey published a note that I sent to him from orbit, and it's the way we feel. If there's a chance that we could take each and every person that would like to go with us, we'd be more than happy to do that. Unfortunately, the system just can't work that way. But if it could, we would certainly accommodate all those that wanted to go. So the best thing we can do is try to come back and share everything with you all. At the same time, realize that what got us there are the hearts and the souls and the efforts that the people have made down here on the ground to get us there. And we definitely do appreciate it. And we are just an extension of what you prepare us to do when we go on orbit. With that, we're going to go ahead and show some slides. Of course, the hardest thing that the crew has to do is to decide on what their patch is going to look like. To take 7 very different people with 7 different personalities, strengths, and weaknesses, and all come up and put a patch together, it takes some work. We did come up with one, and we're very happy with it. We actually had the help of a friend and a coworker here, Mike Santi, and he came up with a very nice idea for us, and we went ahead and put it together. Just a brief introduction. We had lots of flight data file. That's me with some of the flight data file on board. We're going to go through the slides kind of rapidly just so everyone gets an idea of what we look like without a coat and tie on, which is our preferred mode.
And of course, you can't fly the space shuttle without cool glasses. So here's your pilot with cool glasses ready to go.
And I guess I'm about as happy as I can be when I've got a camera with some nice lenses on it looking out the window. So I was real happy here.
Yes, there I am working at the glove box, which was a very neat experiment we had in the middeck.
This was Mission Specialist number 3, European Space Agency astronaut, and I'm here at my favorite spot near the galley holding, holding mushroom soup on my left hand. I'm very happy to be on this flight. I would like to take this opportunity to thank NASA for assigning me to this mission.
Well, this is my mother's son wondering what could possibly go wrong. I guess I found out.
And that was my job on board. I mean, taking care of the computers, TSS activity. And this was actually before the deployment when I was downstairs in the middeck.
As was already mentioned, there was an important international aspect to this mission. There were 3 space agencies, NASA and the Italian Space Agency, which were cooperating on the Tethered Satellite project. And you see Umberto in the middle has the Italian Space Agency patch on his shoulder. And of course, NASA and the ESA were the other 2 agencies. ESA contributed in the loan of 2 astronauts, Maurizio Cheli and myself.
And this is a view of the middeck at the time of the launch. You can see that in this flight we had the glove box that was just in front of Franklin, and he was pretty good. I mean, he didn't feel anything different with this big thing just on top of it, because we are sitting on our back, of course.
Well, here's a vantage point you don't get to see every day. You may be wondering who took the picture. I'll just let you ponder that. But the orientation is you're up on the nose of the shuttle looking down at us sitting in the flight deck on the pad there. Pretty interesting view.
That was a 2-person job to take that picture.
Actually 3. I was.
Okay. Yeah,
I was more sighting the camera.
we're going to go ahead and show the movie. There's Columbia. She was all ready to go on launch morning, just waiting for the crew to show up. And here comes the crew, and of course the thing that's upmost in a crew's mind is what does SimSoup have scripted for us that day? And the best we can hope for is an on-time launch, and this was my third flight and my third on-time launch, so I'm very grateful.
Well, I was a rookie pilot on board, so my eyes were real big staring at those main engine gauges about this point. Of course, the left engine said 40%, so we were convinced that we're not going anywhere. We're pad abort today. So we were getting ready for our pad abort, and all of a sudden, the main engine's SRB's light. Well, it's exciting enough to ride the rocket, but it's even more exciting right about now because we also have the fact that the computer's not talking to the engine, at least it says so. But Andy calls the roll program, tells him what we got, and the ground comes back and says, you got 3 good engines, so we're off to space. It's a heck of a ride, especially for a rookie. I mean, it's just a tremendous amount of power. It's smooth. It shakes on the SRBs, but once you come off the SRBs, it's like an electric jet going as fast as you can imagine. Probably the most awesome sight during ascent was leaving the Earth's atmosphere behind and going into the darkness of space. Quite a ride.
As soon as we get into orbit, we have to configure the shuttle for orbit operations. This is a nice picture of opening the payload bay doors. You can see the shadow of the starboard side of the shuttle on the door and the Earth in the background. There's some spectacular visual effects soon after you get into orbit. We're in the post-insertion period, we're using primary thrusters, and a lot of the ice which is formed in the main engines, because we're burning hydrogen and oxygen is coming out as crystals. You could see the RCS fire in there. It's quite exciting.
And next is the view of the flight deck. 1 hour into the post-insertion, you see somebody still wearing the underwear. But we were already hungry, and you can see we had a big appetite at this point. Everybody felt great. And this is a view of the first sunrise on the cargo bay. On the foreground, you can see the tethered satellite. On the background, there was a USMP.
Well, a lot of stuff to do, lots of equipment to set up, computers, cameras, video stuff, audio, lots of wires, and all of it in preparation for the big moment, which was the deployment of the tether. And here I'm setting up one of our major computers, which not only helped us on the science, but also to keep in touch with the ground and also our families down in our homes.
Next, there will be some shots about the boom deploy. We are very much into pre-TSS deploy activities. The first thing, of course, is to deploy the boom. The purpose of the boom was to basically take the satellite away from the orbiter structure. This is an accelerated view, which normally would take about 12 minutes. The boom is an incredible piece of engineering. You can see it in these shots. You can see the actual tether in the middle and all the electrical wires. The satellite was lodged on top of the boom, and just underneath the satellite you could see what we call it a vernier motor, which was basically an auxiliary motor which helped extract the wire. We had an attitude, this kind of attitude, while flying basically backwards with the nose pitched down about 40 degrees, and that was due to the particular dynamics of the deploy profile.
This is the initial flyaway of the satellite. It's pushed by 2 sets of 2 Newton thrusters, so very small thrusters pushing that half metric ton satellite upwards, cold gas thrusters. Everything happens very slowly at the beginning. This is accelerated 3 times, but the velocity initially was about 1 centimeter per second. Everything went very well at this time of the deployment. Everything was controlled, and you see here a little later the tether is taut, which is always something we desire to see. Because it's much more controllable this way. Slight oscillations, but we were predicting those, and that was not a problem. So a very controlled initial phase of the deployment of the tethered satellite.
We're going to see a few sequences here of the phases of deployment. This is the early phase, and as you see, it looked pretty straight, low tension, and you can see a little bit of the wiggles of the tether in the bottom, but everything completely nominal. The tether speeds up, and it gets to a high speed of about 2.2 meters per second maximum. And as it does that, it begins to, of course, develop a little bit of a bow. And you can see the bow as it begins to grow, as the tether gets longer and longer. Of course, as the tether gets longer and longer, also begins to generate more and more power. We were generating quite a high voltage and, of course, able to collect lots of current. And all in all, on the order of about a couple of kilowatts of power were being generated. You can see also the progression of the bow at this, in this long shot picture near the satellite itself.
And at 19.7 kilometers, we were looking at the shape of that bow when I started to notice, you look at the left-hand side, some waves going up and down the tether. Clearly the tether had gone slack, either because of a jam or a tether break. Looking back, we quickly saw that, in fact, the tether had broken. This was a very, it's a big shock. It's kind of an empty feeling in the pit of your stomach when you look and you realize that there is the tether moving away from us at about 80 feet per second, and you just wanted to reach out and grab it and pull it back. But, of course, there was nothing we could do. There you can see the end of the tether coming up in the lower part of the field of view. And so at this point, of course, we have some procedures which we're trained in.
Basically here, at this point in time, there's 4 of us that were awake, the 4 veterans, the 3 rookies were sleeping. And of course, the very first concern we have is to make sure that none of this ball of tether starts coming back towards the orbiter. We were concerned pre-flight, and we did a pretty good share of training pre-flight that if we had a ball of tether coming back at us, we'd do the proper evasive maneuvering to make sure we didn't have a big problem. But it all stayed with the satellite. The tether actually broke inside the boom, so there was nothing required on the orbiter side of the house other than to monitor the satellite.
And this is all that's left, or that was left, just a stub of tether, and in close view with a very powerful lens we had, we could see that it was charred and it was burnt, and this was further confirmed later with the hardware at the Cape. There was nothing much to do except to retract the boom and really get ready for the remainder of the flight, which was concentrating on microgravity science, and it was a whole mission to do. These spectacular views actually were taken from the ground by Paul Maley from MOD. He was in Australia, and he was able to capture a glimpse of the tether, and you even see a meteorite go by just for a glimpse there. So we are very appreciative to Paul for being able to do that.
After the tether was over, we still used the top camera that was supposed to be used during the tether activity while we had current flow in the tether to observe glowing. And we used to point to the Earth glow and to the lightning that we had during our night pass.
A lot of things behave strange in weightlessness. You've seen pictures probably of astronauts doing strange things with water drops. They behave very counterintuitively. Claude has a little goldfish here, which he's putting in a tank. Of course, and we can blow air bubbles inside the water bubbles. But other things behave strange too, such as flames, combustion, and we did these combustion experiments in orbit.
And here is the place where we did them, this glove box facility, which lived in the middeck, and in it we actually burned different kinds of materials. This is one of them. It's just a birthday cake candle, just like what you see on the ground, but the flame looks a lot different. It's more round, and it's more determined and controlled by the amount of oxygen in its proximity. And when the flame extinguishes itself, the smoke just stagnates there inside the cavity, just like what you see. It's not dominated by convection or anything like that. The flow has stopped. If we actually induce a flow, you can see what happens. It's very laminar, very slow, and we use this to test some of the new generation smoke detectors.
This is another one of the combustion experiments called Thrifty. You can see all the little numerical data is giving temperatures of the probes you can see in the flow. It's a cylindrical paper type sample, and there's a very low flow. The little ball on the left side is showing you the flow in centimeters per second, and this sort of looked like a jet engine to me.
And here comes another combustion experiment, RITSI. We are burning paper samples. In this case, a flash lamp is used to ignite the sample. And the setup was such that there was air flow circulation from the right. And in fact, you see that the flames tend to go to the right. That is quite uncommon with respect to the experiment we do on Earth, while the flame is trying to go the other way. And you see that, in fact, the flame is on the right until all the paper is gone, and then it starts to move on the left.
RIGSIG, which stands for Radiative Ignition and Transition to Spread, basically had used paper samples, but two different types of investigations. One was a flaming investigation, which you just saw, and the next one we'll see was basically a smoldering investigation. They were carried out inside this enclosed compartment, which was called a glove box, which provided a safe environment for combustion experiments. Even this sample paper was ignited by radiative, by radiation, and the smoldering was really very interesting. As you can see, it assumed forms which are quite strange. Somebody said, "Don't let the animal out of the cage there." And the scientists are still working on the data we brought back from space to explain all this.
Well, we're doing all that in the middeck. Out in the payload bay, we had a lot of microgravity experiments. This is a picture of some of those. And one thing to be careful with is like if you were doing exercise. So here I'm on the ergometer, and it's not during a microgravity period, obviously, because this actually could shake the whole orbiter, and we had to be careful of that.
Even a simple activity like moving into the cabin has to be done carefully when you are in a microgravity environment. We had the accelerometer on board that allow us to see real time our contribution to the micro-G environment, and that was very useful to keep it very low.
Of course, there are lots of other things you can do while being quiescent, for, of course, eating and taking care of the cabin. And of course, we had to update all our documents. The updates came up on a sort of fax machine that we had on board. And with Scott and Umberto, as first-time flyers, we tried to spend as much time as possible, free time, of course, looking out of the window. Here we are flying over Chad, and unfortunately the movie doesn't really do justice to the real colors that we will be able to see from space. We are around the Tibesti region, and the colors are really, really bright and vivid, and this is something that really catches your imagination. After this, we'll move on to the Nile Valley, which is, of course, one of the places that is very easy to detect from space, because you can really see the difference between the green of the area around the Nile and, of course, the desert around it. We tried to take shots of the pyramids several times. Unfortunately, we always overflew the pyramids around noon, and so we couldn't use the shadow to detect them. And strange enough, there was always a thin cloud layer hanging over the pyramids. Maybe next time.
Then we flew out into Asia, and this is a zoom shot of the Mount Everest region. You can see Mount Everest right in the middle, Makalu below it, and the Aran Valley. And then we zoom back, and you see really the whole Himalayan massif with the Indian subcontinent on the left crashing into the Tibetan plateau on the right. And if you take a strong zoom lens, you aim it at these mountains. This is the easternmost part of the Himalayas. That's the top of the world. And we're overflying China now, actually out over the Pacific Ocean, and you can actually see the Himalayas set behind the horizon. It's a pretty spectacular view. It really puts you in orbit.
One of the very important things to us on board, obviously, is our personal mail from home. This is just a picture of coloring that my daughter did.
This is what a water dump looks like in space. The water immediately crystallizes to ice crystals, and as we are crossing the Terminator, it's really a beautiful sight. We were doing this periodically to maintain the water in the tanks on board the orbiter within predetermined limit. And this is Jeff and I looking out the window at the sunrise. And during the night, we had a lot of moonlight during the nights, and you see these crystals of ice that are following us and are twinkling in the over the moonlit landscape. Really beautiful view during the night.
Well, it's been one heck of a journey. We've done a lot of experiments. We've seen a lot of great sights. And now you can see the folks on your flight deck. Your pilot with his glasses again, ready to go. And we're all ready on the flight deck in our suits, ready to come on home.
And the same situation seen from the middeck. We were very busy getting ready for re-entry, and you see a lot of stuff floating around, included our parachutes that are still up in the air, you see. And we have to do this twice because of the extra day.
This is the last pass over the Himalaya, and you see the full moon, or nearly full moon setting. It's always very impressive to see how fast the moon and the sun rise and set. And this is the view of the moonsets with a telephoto lens, powerful telephoto lens, about 400 millimeters. And due to the differential refraction in the atmosphere, you have the whole moon that is completely crushed as it penetrates the lower layers of the atmosphere. Very beautiful sight.
And now we're re-entering. If you look closely, you can start seeing kind of a red glow out the side window there. As exciting as launch was, re-entry was just as fascinating, especially as you come into in the atmosphere going Mach 25. The sky turns a pink and then a deeper and deeper red and orange. And then you break out, and then you can see below going a mere Mach 15 over Houston. We went zipping by, and Andy was nice enough to leave us in a right bank so I could look out my window.
Those puffs of smoke are the RCS jets that shut off just prior to Mach 1 as we're coming into the Kennedy Space Center. We did have a wave-off day, but finally it was a pretty day. There's the east coast of Florida going by Scott's right window there. And we're in a right-hand turn here to land on KSC runway 33, heading towards the north. Atmospheric conditions were great that day for the folks on the ground to see us, as well as when they heard us when we did our double sonic boom. So we made some nice contrails coming around. The vertical assembly building's out on Scott's right window again. This is over his shoulder. As we come on back in, it's the standard world's worst glider at this point, 300-knot dive, 20 degrees down to the ground probably. And Scott finally gets the gear out down there at about 350 feet. But that was just like we had planned. And at that point, we continuously decelerate as we're coming across the runway. The shuttle training airplane, which had been giving us a lot of our landing data previously, is coming by our left-hand side there. Tried to make the black marks there, but landed just a little bit short. Some wind shears that day and headwind helped me do that. We put the drag chute out to continue the deceleration process. It's a real hard thing to do, to lift your legs up to get on those brake pedals, and you got to do it because you don't want to look bad on CNN. So I get the legs up there, get on the brakes, but the deceleration from the drag chute provides us quite a bit of deceleration, so it's not that hard of an effort. We dropped the drag chute off at about 60 knots or so, just prior to coming to wheel stop, and we were just real happy to be home.
A few minutes into post-insertion is a very busy period, as you can see here, and we are trying to get rid of our suits and make room for all the stuff that we have to stow.
Well, there were 3 rookies on the flight, and this is just after getting to orbit, and as you can see, everyone said, you know, be careful, you may not feel good. We all felt great, so I decided to just come on diving down the hatch into that mess downstairs to let these guys get me out of my suit. And I'm probably smiling because I know I'm going to get out of my suit here soon.
Well, unpacking for 7 people for 16 days in that little tiny place is a big job, and we had to make the airlock the place to put all the stuff, and of course it also had to be somebody's bedroom, so we have to make provisions for somebody to actually sleep right in there.
We are already into the payload operation activity. You can see the satellite just left the top of the boom, and on the satellite you can see the nitrogen, small nitrogen jets that they use to provide some initial tension for the tether.
This is a view of the aft flight deck during the initial flyaway of the satellite. And as you see, there was a very high density of bodies in the aft flight deck. Franklin and Scott went forward flight deck, and you see Andy on the left flying the orbiter. Jeff is in the middle, guiding us on the procedures and using the binoculars. I was busy with operating the CCTV cameras, and Maurizio is using a laser rangefinder to determine the range and range rate of the satellite. So it was very busy, but everything went well in this initial deployment, as I mentioned before. But each of us had certain procedures he had to perform in case we were going to have problems. So it was a big team effort.
The satellite actually, as it left, did not go completely straight up the boom like we'd liked it to. And on STS-76, the first flight of the tethered satellite didn't do that either, but it was such an easy thing for us to do because we had seen it and practiced it so much in our simulations that having the satellite go out a little bit cockeyed was just a simple thing to do. And all I needed to do was keep the orbiter, I had to do some maneuver, but keep the orbiter within a little bit of a cone to make sure that they didn't get too far away from us.
And the TSS science worked really flawless during deployment. We could verify the power generated while the tether was reeling out, and actually was completely nominal. I mean, we got very good data during this phase.
Well, that's the sad picture after the tether did break. And as we said, there wasn't very much we could do with it except shed a few tears. Trying to cry when there's no weight to pull the tears off your face is...
Well, we had a few opportunities to actually take a look at the tether, fly over, and this is one of the pictures taken with long lenses that we had. And I should also say that serendipity plus the quick response of the ground controllers was able to define a new type of science. I guess we call it the detached science. And they actually turned on the instruments in the satellite and were able to do a whole bunch of new observations that were not expected. And also, after tether was over, we needed to get ready for all the microgravity operations, and that all came in instructions from the ground in miles and miles of teleprinter paper, which would then have to sort out and put in our flight plan and execute it.
Here we are very much into the second part of the mission. We started concentrating on mid-deck activities. We had basically three investigations that all had in common burning. We all became pyromaniacs in one way. And we used this mid-deck glove box to provide safety for the shuttle. This is a montage of a sequence of burning. In particular, this experiment is Ritzy. As you can see, the flame, and we used, normally we used video cameras to catch the whole burning sequence on videotape, and on top of the mid-deck glove box we had the 35mm camera to take these shots. What is really astonishing is that the flame tends to be spherical and is counterintuitive. It tries to move into the basically upstream instead of downstream. The flow in that picture was coming from the right side.
We had an immense amount of photo TV requirements for all of our payload, plus some of the events to do just with the public affairs. I felt like we had about as much electrical outlets and cords on board as we did tether that was floating up there somewhere in space. So it was quite a handful and very crew intensive getting ready for all the photo TV requirements.
A very modest experiment, but nevertheless a very important one, was carried out in protein crystal growth, and was the first experiment from a joint effort between the countries of Latin America, among the countries, and it was an effort to look for potential drugs to combat Chagas disease, and we'll be looking to see more of this in the years to come.
You can't see us as well as we can see you down here sometimes. But this is just a shot of the Houston area. The Intercontinental's up there on the upper center, and Johnson Space Center, clearly that area is down there towards the bottom right.
Going to space, I was really surprised how easy it is for the human body to adapt to different environments, and I think this picture shares basically the same flavor. This was taken on the Sahara. In the Sahara, you can see the dunes there, an incredible view, and on the bottom right corner there's a human settlement.
This is a good shot of the Nile River. On the upper left corner there is the Luxor temple. The big contrast between the green part and the surrounding desert give you an idea how important is this piece of land for Egypt. Almost 95% of the people lives in this area, even though it's only 5% of the entire land in Egypt.
A little later in the flight, we got this wonderful picture. You're looking at the southern tip of India, and you can see the little land bridge going over to Sri Lanka, and it's a fairly unusually clear day in Sri Lanka. It's just a gorgeous shot.
This is a view of East Himalaya and what I would call the big bend of Brahmaputra. Brahmaputra is a very long river, about 1,800 miles long, and it starts in the high Tibetan plateau, close to the top of the picture, then flows to the east, which is toward the bottom of the picture, north of the Himalaya, then makes a bend through these very narrow gorges that you see in the middle of the picture towards the left, and then you see it takes a course to the west on the left-hand side of the picture. It was amazing to see the different climate that you have here. You have the high Tibetan plateau, which are rather dry. You have the Himalaya with all these high mountains and ice and snow, and a very wet area on the left-hand side, northern India and Bangladesh, that gets up to 400 inches of rain per year. An amazing picture. And here, if we follow the course of the Brahmaputra from the lower end of the picture towards the center, then it turns to the left and it joins with the Ganges that comes from the upper right corner of the picture through Bangladesh, and then it goes via the area of Dhaka, the capital of Bangladesh, in the Bay of Bengal. Really a very, very clear view of this part of India and Bangladesh. Very unusual.
For all the beauty of the Himalaya, as you fly out over China, you see here the Red Basin, where the increasing population and the use of coal-burning fires has created a pollution which has been measured now to be increasing over the last 50 years. We have extensive records going back that long, and so it's almost like a laboratory to study the effect of human beings on their environment.
Well, the extra day in space provided us with this unusually clear view of Costa Rica. You can see almost 90% of the country, both coasts, and is basically looking from north to south. You can see under the clouds in the center there, the city of San Jose, my hometown, and you can see my home is right over there to the left. Actually, my mom told me that it took me 1,000 hours to take this picture, so I guess I must be getting better.
With such an international crew on board, we all tried to have an opportunity to bring in some of our ethnic food from our cultures and our backgrounds. Of course, Philadelphia soft pretzel is about as ethnic as I get. But we did manage to bring some on board. It was a great food, especially for the first and second days while we were up there and while they were still fresh.
We had a lot of food on board, but the two Italians had to fight for the last piece of Parmesan cheese that we bought on board.
And I think personally that the use of Swiss chocolate should be mandatory on every space flight. It has been on every flight I was privileged to fly on, and this time the Swiss chocolate had the shape of an orbiter. This is white chocolate, it's in the middle of the picture, and in the bottom in one hand is a tethered satellite in chocolate also. So we ate quite a lot of chocolate on this flight. It was very good.
Well, towards the end of the flight, when we were getting a little tired of space food, Franklin whipped up some dynamite burritos. He's got all the ingredients here, and we thought you'd like to see just how you make burritos in space. So we've got the refried beans, which he brought up in natural form, and spread that on the tortillas, which tortillas actually are great in space. If you don't eat them, you can make frisbees out of them. So. Put on a little cheese, which you have to squeeze out of a tube, but that's space flight, and put on a little taco sauce, Tabasco to taste, put in a toothpick in the oven, and whammo.
And of course, the best part is getting to eat the burritos, and not having Mexican food for quite a while, I was very appreciative of Franklin's handiwork. It was just wonderful.
This is another meal. This is the Blue Shift meal, and we had a mentor for the distinction of this meal, Jeff Hoffman himself, who doesn't take meals very lightly, neither on the ground nor in space. And he suggested that we have a formal meal, the whole blue team, and we went in our sleeping stations with trays, and we had napkins, and we had appetizer and entree and silverware, and we were listening to classical music while we were eating this meal.
This flight was very special for Franklin and me, who completed 1,000 hours of space shuttle time. So we were quite pleased with that. And we're looking forward to lots of other people joining the club, but it's nice to be charter members.
Well, I think I made Andy nervous, because every time he'd wake up, he'd find me out there with the tools, because I was looking for something to fix. And good news, bad news. Good news, orbiter hardly ever broke, so there's hardly anything to fix. Bad news was I didn't have anything to fix most of the time, so I just played with the tools.
Just another shot when we finally got together again. There's a little gray blotch there on my head. It wasn't there before the flight. So maybe it's a misprint in the color on this flag.
Flying in space, especially for a first-time flyer, is also means a lot of emotions that are very difficult to transmit or to catch, basically to describe it with words or pictures. And this is basically what this picture is standing for. I mean, there's a beautiful view of Earth and everything that represents.
But flying in space is no less emotional for a third-time flyer like myself, or for people who have flown thousands of hours in space like two of us. This is a view at night, shortly before sunrise. We had the cargo bay illuminated by the moon, and you see the Earth underneath with the air glow. And the sun is starting to illuminate the tail of the orbiter, and you can still see stars. In fact, the stars, the two bright stars that are just to the right of the tail are Alpha and Beta Centauri. And a little further to the right, we had the Southern Cross. And you see also in the atmosphere on the left-hand side the beginning of dawn just before sunrise. Really beautiful sight. It's incredible.
We try to share with all of you some of the beauties of spaceflight, which does make it so special for all of us who have been privileged to be up there. And of course, 16 times every day you see the sun rise and the sun set. And the colors are a little different every time depending on the atmospheric condition, but it's always beautiful. And this is a kind of a slow motion montage of what the payload bay looks like as the sun gradually sets on it. And that's kind of a nice thought to bring us back to Earth.
Space flight, of course, has all the thrills, chills, challenges, and rewards that anyone could ever want. It's an honor and a privilege to have the opportunity to go. But as much as we do go and as much as we enjoy it on board, it's also extra special, and we certainly look forward to coming home. Columbia there, that started out as a rocket ship and turned into a spaceship and came back as an airplane, albeit it's a different kind of airplane than most airplanes. But that was our home for 16 days, and we were happy to be here, and the crew was doing great, and we did our walk around and tried to express our appreciation for such a great machine.